So the James Webb Space Telescope is NASA's next flagship space telescope. It is a collaboration between NASA and the European and Canadian space agencies. It will address a wide range of scientific topics, but first and foremost, it will detect the first galaxies in the universe, and it will characterize the atmospheres of exoplanets around other stars.
Get notice an hour before the contact.
Webb's mission to understand exoplanets, I think, goes really to some of the core of our humanity, these fundamental questions of, are we alone in the universe? Where do we come from? Where do we go? The universe is so huge. You'd think that out there somewhere there will be life, but we don't know. We have to build large instruments to tell. And Webb will make a big leap in that direction. Also, because the telescope is so large, it doesn't fit into the rocket that will launch it, so it has to be folded up. It has this giant primary mirror covered in gold, 21 feet across. It doesn't fit into the fairing, so it has these two side lobes, like ears, that are folded back. And once it's launched, it will unfold in space to be able to conduct its primary mission.
The Earth is here. This is the Earth. And then we have the moon going around the Earth. And the obvious place we're going to put the telescope is orbiting around this one over here. This Sunshield is quite remarkable. It deploys, as I said, about the size of a tennis court. There's 5 distinct layers. And on the sun-facing side of the bottom layer, the temperature is about 250 degrees. And on the telescope-facing side of the top layer, you've deflected so much of the light that the temperature is minus 375 degrees, or only 36 degrees above absolute zero. And that keeps the telescope, the instruments, and everything about it cold so it can detect these faint signals from distant space. James Webb Space Telescope is often called the successor to the Hubble telescope, but that's really slightly a misnomer because, first of all, the Hubble telescope is still operating and may operate for another 5 or 10 years if we're lucky. And secondly, it's a very different kind of telescope. The Hubble telescope is optimized to see the part of the universe that our eyes can see, whereas the James Webb telescope is optimized to see in the infrared part of the spectrum, which gives us a whole different set of information about the universe.
A telescope is really a time machine. Because light travels at a finite speed through the universe, we see the universe as it existed when that light was emitted. It's traveled through time and space, and we detect it later on. For instance, if you want to have it in comparison, you look at the moon. It takes light about 1 second to travel from the moon to us. So we see the moon as it was 1 second ago. We have plans for the first year, where things that we think we'll see. We think we'll see the first galaxies. We will characterize the atmospheres of exoplanets, but we will find new things that we have no idea exists right now. And I'm so excited to find out what that is.